whole purpose here is I think what you're doing is terrific, and I happen to like you a real lot, and I want to do everything we can to get your word out and help in some way. So that's why I had breakfast with David and talked to him about you, and he's super interested.
Thank you.
And that Lauren, John's wife, does his work. I just found out
Uh-huh.
30 seconds before I brought him in here, but that could be wonderful.
Yeah.
So, so Jonathan Sackner-Bernstein, we met probably a year and a half ago. We were introduced by our friend Seth Godin, who is one of my heroes and one of your good friends. And he's a terrific guy. And he said, anyone he says I should talk to, I want to talk to him. I'm so glad he introduced us. And I love what you're doing. And I want to share with our audience today who you are, and what you're doing, because I think it's fascinating. And I'll give the layman's version. You're a practicing cardiologist at the time. You live in Westchester County, nearby our friend Seth. And you had one buddy develop Parkinson's, and he succumbed to it. And then you had another buddy develop Parkinson's, and he said to you, Jonathan, you got to help me. And you said, help you? I'm a cardiologist. I don't know anything about neurodegenerative diseases more than anybody else. And he said, but you're the smartest guy I know, and there's got to be something you can do to help. And you decided to try. And to the extent that I think it's amazing, the original foundational research that the whole field of neurodegenerative diseases, particularly Parkinson's, is foundationed on is work that was done in the 1960s, and it was done in Germany. Ergo, the foundational research is published in German. And you taught yourself German well enough that you could go back and read the original papers. I think that story is amazing
Well,
and will play well in the movie.
you're giving me way more credit. It was I didn't teach myself German. First, it was hard to find the papers. With all of the papers
I
that
don't
are
know if you heard
available,
about this internet thing.
yeah, with all these facilities and research databases that are on the internet, these papers I could not find, and I'm reasonably good at searching on the internet. It's not that hard. You know the names of the authors and the journal title and year. I ended up remembering that the old journal collection from Columbia, where I was on the faculty as a cardiologist, that they had kept down in their basement, which I used to like to thumb through for all these classic articles that are 100 years old,
Uh-huh.
was donated to the New York Academy of Medicine. So I called up the New York Academy of Medicine and said, hey, I want to try to find a paper that I think you might have. And I had to make an appointment and go in and give them the citation. And then they went into the archives. You don't want mere mortals like me touching the originals. And they would bring it out and show me the book. Is this the right one?
Yeah.
And I said, yes, that's it. They said, "Oh, hold on, don't reach out. We'll be right back." And they brought me back a Xerox copy. And so then I had 4 articles as Xerox copies in German. And I was not so good that I could teach myself German. But at that point, we already had Google Translate. Now I couldn't get it to upload the files.
So you only had the
And
Xerox copy.
right. So what I started to do is I started with the methods section and typed in sentence by sentence.
Now,
And
how extensive was this work?
it was pretty detailed scientific stuff.
Yeah.
Um, and typed it in a sentence at a time, and then I had the methods translated in English, and then I could look at the figures and tables of results and understand what they were measuring, what their data actually showed. And then I could really start digging in and understanding that in the context of the literature that I had started to read already.
Mm-hmm.
And what I learned was that their science was really very, very good. Their methods were very tight. The problem was that in the 1960s, they didn't know what we knew by the 1980s. So they were measuring the tissue levels of dopamine, where they would take a chunk of brain tissue and mash it up
And this
into
is post-mortem,
post-mortem.
because it's not so nice to do pre.
People would not generally consent. And the levels were low, and that's been replicated in the tissue.
Yep.
What we learned by the 80s was that it's not the tissue levels that's important, which includes the fluid that's outside the cells and inside the cells. It's all about what's inside the cells.
So at a cellular level.
At a cellular level.
So as I understand it, they'll take a piece of brain tissue, they'll mesh it in a dish, and then they'll measure the components there. And by doing that, you're getting the fluids that are inside the brain, outside the brain, separate from and you get also getting the fluid levels inside the cell, but it's not indicative of what's existing in the brain within the cell level.
Right, it's all mixed
Yeah.
together. So I started
So you could have an excess of a dopamine in the outside fluids. It doesn't represent what the dopamine level is within the cell.
correct, and vice versa.
Yes.
And by the time I found the papers and had them and
Because the whole
translated them
theory is that it's a lack of dopamine is foundational here in this research is what causes Parkinson.
exactly. And so from the 1960s, with a highlight in 1969 of the first treatment being approved by the FDA, all treatments have focused on either adding to the amount of dopamine by giving a dopamine drug
Yep.
or by making the dopamine that's in the brain work better, work stronger. So it's all about making more dopamine to try to fix what is believed to be a deficiency.
And you and I have chatted about this before. Your assumption here, your hypothesis, not on the science level, but on the scientific community, is that once you've spent your life with a point of view, and once you've been teaching and treating people all of your career on this foundational assumption, it's very difficult for people to say, wait a minute, it could all be wrong. It could be the opposite of what we thought. And your behavioral analysis is that's very difficult for people to do, which is why you're having resistance at the corporate level, at the pharma level, at the clinical level, and at the research level, because people just don't want to believe that someone who doesn't come from the practice, who's a crazy cardiologist, hasn't studied this his whole life, could have actually tripped onto something that throws everything we thought we knew out the window.
Well said, and unfortunately, very accurate. And I think that what's interesting for me is that I've been in situations multiple times where there's been an alternative path available, visible,
Yep.
potentially pursuable. And in pursuing those paths, we ended up finding that our understanding of the disease was wrong. And these new therapies came to be. So, as an example, when I was training as a cardiologist, I was lucky enough to be the research fellow starting the first phase 2, which is a mid-stage clinical trial, first phase 2 clinical trial of a beta blocker for the treatment of heart failure. Heart failure is where you have a weak heart. And at that point in time, if you pulled open the old PDR, physician's desk reference, that, is like this is this thick with the labels for all drugs, and now we can get them on the internet, of course.
Yep.
All of them at that time basically said, don't use beta blockers in people with heart failure. They're going to make them sicker. But by that time, there were a couple of cardiologists in Sweden who had figured out a way to introduce the drug at a low dose and gradually increase it that people could tolerate. And eventually, the pharmaceutical industry said, this is worth pursuing. I had a few mentors in my training who told me, are you sure this is a good idea to get involved with this trial? And I said, I think we've been treating the disease backwards. We were treating the disease of heart failure with drugs that were beta agonists or beta stimulants, like adrenaline-like substances, sort of like the way that we currently treat Parkinson's with levodopa, which
Yes.
is dopamine. And by the way, dopamine and adrenaline are very closely related chemically.
Mhm.
We did
Just
this.
found in different places in the body.
They're in some different places. There's some same in the same places,
And
but
does
there's
the liver make
one.
both?
The different cells make, like in the brain, you can make you make dopamine, and then then you from there. There's one synthetic step inside the cells that turns it into adrenaline. So
Okay.
they're very closely related.
Yes.
Um, and what we learned was that by taking this opportunity to reevaluate whether we were looking at heart failure right, we ended up discovering that beta blockers not only worked, but they made people feel better. They made people able to function more. They improved heart function. They reduced hospitalizations, and they made people live longer.
Wow.
It's like everything you could ask
But it's
for.
contrary.
And
Contrary to
it's
what the
contrarian.
point of view was at that time.
Right, and I think there's a strong parallel in the cell biology between heart failure and Parkinson's, diseases where there's some trigger that makes the body realize it has to compensate for an injury. So some of the nerve cells are lost or dysfunctional. The remaining neurons, dopaminergic neurons, kick in and start making more dopamine to try to compensate for their brother and sister cells that are out of commission,
Uh-huh.
but it doesn't turn off. So acutely, that's a great response, but if it stays on chronically, it causes toxicity. And that's what we see.
October is National Disability Employment Awareness Month, a time to celebrate people of all different kinds of abilities. This year, Smile Farms gathers for our 10th annual gala here in New York City at the Ziegfeld Ballroom. It's a wonderful time to celebrate 10 years of creating wonderful work and job opportunities and brighter futures. I invite you to join us. Visit smilefarms.org to be part of this wonderful celebration. Help us prepare for the work that lies ahead. Wow. I remember more than a year ago, you and I were on stage at a conference that Worth put on in Boston. And I plucked you out of the audience because I thought your story was so good. And we had 10 minutes on stage together. And you told me the story about, we were talking about in general, how discoveries don't often come from outside the field because this is how it is in our own field. Oh, I know everything about the flower business. And someone comes up with a great idea and they had no idea what was going on in the flower business. Some would argue that we did that to the flower business a
Yeah,
long time ago.
yeah.
And maybe there's a little truth to that. But you told me the story about two doctors in Australia who changed the world in terms of how we think about ulcers.
Yeah, it's a pretty amazing story because it was a gastroenterologist who was mostly clinically focused, not research focused, and a pathologist who also was mostly clinically focused, not research focused, who noticed in some of the specimens that they had obtained by biopsying ulcers, stomach ulcers, and stomach inflammation, gastritis, which most of us are familiar with that term, that there were these little flecks that looked similar to bacteria. And so they decided to see if they could culture bacteria out. And in fact, they could. And I may not have the story exactly right, but
Directionally there.
it's pretty close that people basically looked at them and said, infection causing gastritis and potentially gastric ulcers? You're out of your mind.
Hooey!
It's about stress.
Yes.
It's about
We
too
know
much
that.
spicy food. We've proven that. This is known. And at some point, obviously, they got so frustrated that Barry Marshall, the gastroenterologist, took the following approach. He had one of his colleagues do an upper endoscopy, document that his stomach lining was perfectly normal. He then drank a broth that was filled with this bacteria, H. pylori, to infect himself. Within a week or two, he started having some stomach distress, shall we say. He had his friend endoscope him again. The lining of the stomach was inflamed. They biopsied it, and sure enough, they grew out this H. pylori bacteria from the biopsies. He then treated himself with a cocktail of antibiotics that in the lab looked like it worked. And of course, there's no way he could have known that.
Yes.
But he took these antibiotics for a couple of weeks.
Standard available antibiotics.
Standard, yeah,
Just a new cocktail.
A cocktail that included Pepto-Bismol as one of the three,
Is that right?
interestingly enough. And
Just for color.
no, I think for its bismuth, the activity of its bismuth. And a couple weeks later, felt better, had a repeat endoscopy, and his stomach was normal.
Amazing.
So he proved it on a study of one.
Yeah.
Don't
At great risk.
at risk, and don't look at me. I'm not about to give myself Parkinson's disease to prove my point.
Thank you. So your work is done. You did this with your friend. You came to this. What if everything we think is true isn't true? Then you went on a path to say, is there something that could, can we treat this with a drug? And if we can treat it with a drug, what would the compounds have to be? And you said, wait a minute, is there an already patented drug that had the same effect, but clearly it would be patented for another use? And how did you come to your discovery of RB190?
Well, once I got to the point where I had done the math to show that the levels of dopamine inside the neurons that control movement were markedly abnormal, I could have done what most people seem to do, which is they find something abnormal in disease and they immediately hit the press and say, "We've figured out the cause of the disease." And those of us who have been around the block
Well,
know
you
there's a
you haven't been
difference.
to causal. You're
Well,
one step after causal, right?
well, at that point, all I knew was that there was a relationship. I
Yes.
couldn't prove cause. So
Yes.
there's a correlation versus a causation, something that goes along with the disease versus causing the manifestations of the disease. I
Yeah.
did not know. So instead of doing that, I thought I need to do a lab study on an animal model of Parkinson's and find a drug that I can test and see if it actually reverses the disease in the lab. So as I'm starting to read, trying to figure out what kind of drug that would be, I went through a couple different ideas of what kind of drugs. And I was really looking at this from the point of view of old-fashioned pharmacology. In the olden days, starting in the 60s, really, it became very popular. You would isolate a receptor on a cell surface that was responsible for some process in
Transient
a
activity.
cell,
Yeah.
and you would either stimulate it or block it,
Yep.
right? Then
X's and
there's
O's.
yeah, then there's the idea of, well, you've got a protein that's involved in the disease. I'm going to either increase it or decrease it, and the way to do that is you find the rate-limiting enzyme forming it or the rate-limiting enzyme degrading it.
Mhm.
So I wanted to reduce dopamine, so I did the old-fashioned, sort of like the way all the statins work and so many drugs that are on the market blocking enzymes. I looked for drugs that block the enzyme that's responsible for forming dopamine and found this drug,
Mhm.
which we call RB190.
Uh-huh.
It was approved to treat a rare complication of a rare cancer in 1979, developed by Merck. Really is not used very much, is still on the market.
Mhm.
Um,
And Merck still have the patent?
no, once it went generic,
Oh, it went
Merck
generic.
offloaded it. It's gone to a couple different companies,
Mhm.
and a company owns that original approval and still sells some of it,
Uh-huh.
probably not very much. Um, and so then I looked at how to design a trial with this drug, and lo and behold, I came across 3 studies where the drug had been used in a model of Parkinson's, not with the intention of fixing the disease. In fact, talking to the authors as much as they were willing to talk to me, especially when I told them, "Hey, you figured this out even sooner.
Let's
Let's work
collaborate.
together here," was that they were using it as a way of showing that dopamine was important in the pathology, but in the traditional sense. They expected RB190 to make things worse, and the drug they were testing that they were trying to develop to make things better in those animal models. And lo and behold, the data were the opposite. The standard therapy made things worse, and RB190 reversed the pathology that was measured.
When you say reverse the pathology, layman,
So in
did
in
did it change the symptomology? Did it reverse the deterioration? What happened?
in those first 3 studies, they measured different things, and in all 9 of these models, different things have been measured. So in those first 3, what they showed in one was that the dopaminergic neurons lived longer. More of them stayed alive in this model of disease when they were treated with the drug, so it preserved their viability. And in one other one, they were measuring whether it affected the deposition of a protein called alpha-synuclein that many people believe drives the disease. Certainly, there's more of it in people who are sicker, who die, this is from postmortem,
Yeah.
who die with more advanced disease. And many people are trying to figure out how to develop drugs to remove alpha-synuclein. What what was shown in this trial, this lab model on human stem cells, was that RB190 reduced the amount of alpha-synuclein that was deposited. Again, making the cells architecturally more normal. Subsequent studies.
What do you so your theory, well, the knowledge of and your theory of neurodegenerative diseases, specifically in this case Parkinson's, is that somehow the enzyme that causes the production of dopamine at the cellular level turns on. And then the hypothesis is the enzyme that's supposed to turn off that production doesn't turn off.
It's the same enzyme. Something should turn it off, and it doesn't get turned off.
Yeah.
So it stays
So
on.
that's what causes Parkinson's. What causes that?
So there are a couple things that I think are the answer to that question, but I don't think anybody really knows what the initial trigger is.
Yeah.
There are a couple of animal studies that show that if you expose an animal to um, some sort of injury, one is a toxin and one was low oxygen, both of them in theory not severe enough to cause all the cells to die, but to cause injury, that they then measured that the cells around the area that was injured were noted to have higher enzyme activity and therefore more dopamine. So it looks like it could be an injury like
Trauma?
that. It could be either low oxygen or a toxin. And
Well, low oxygen or a toxin. What would cause either of those?
so low oxygen would
Each of
be,
those.
well, low oxygen could happen when people develop vascular disease. So the blood supply to the striatum, the part that that has the dopaminergic neurons and cables that
Yep.
connect them, called axons, um, that has relatively poor redundancy in its blood flow. It's got, very specific one way of getting blood flow without backup
To the brain.
to that part of the brain.
Yep.
And in fact, what's interesting is that there are two parts of the
It's
brain.
all interesting.
Okay. Well, one of the things that I've realized recently was um, trying to understand why in all of these studies, as people measure the degree of dysfunction in the two parts of the brain that have dopaminergic neurons, called the putamen and the caudate, that the putamen is always more severely affected. Why would that be? I couldn't figure it out. And then I was looking again at the circulation, and the putamen has worse circulation. It's anatomically set up in a way where it's more likely to have a problem transiently with oxygen getting delivered by blood flow. And so it's worse. Nobody's has a theory as to why it's worse. And I ask people that, and they never have an answer. I think that could be the answer. But I think that what's likely to be a major factor is something that was summarized recently in a book that was published and has got a lot of press by two really smart Parkinson's docs, Ray Dorsey and Michael Oken, where they're describing the relationship between environmental toxins, especially pesticides, and the risk of Parkinson's.
No kidding.
They lay it out in this book that's really it's worth a read. It's a fantastic read that, I've seen some of these papers, but I wasn't really focused on the epidemiology so much, so
Because
I missed this.
Well, we're all wondering why are we, I'm affected by it as a family member because I have my youngest brother has Parkinson's. But it's like when we get a red car. Everyone has a red car. I can't believe how much I hear about Parkinson's.
Yeah.
Is it increasing?
It's increasing, but what's really notable is it's not just increasing because of the aging population. It's the
That would be the first assumption.
right, which is how Alzheimer's is increasing.
Yes.
It's increasing way more than can be accounted for by the aging population. There's something that's happening.
Yes.
And
Which-
they make the case that it's these environmental toxins in a way that, reading that book, I was thinking to myself, this is kind of like
Of
what it must have
course.
been like what somebody was reacting to when they read about tobacco and lung cancer.
Yes. Yeah.
I mean, I hope these guys have the staying power to keep after this, because this is a big, really important target. But that's going to take 20 or 30 years. I'm not interested in waiting for 20 or 30 years to
So-
decrease the amount. We have to do something to treat people with the disease now.
Halloween is creeping up, and Cheryl's has just a trick to make it a spooktacular success. Scary good treats that'll make your little monsters but scream for more. Conjure up wicked Halloween fun with Cheryl's cookies.
Yes. So toward that, in what form would your RB190 drug, soon to be called the Sackner-Bernstein dosage, in what form would you give it to patients?
Well, first of all, if it were to work and I had the chance to name it, I'd name it for Ivan. But
Ivan's your friend that you lost to Parkinson's.
yeah. But the drug that's available that you can theoretically have a doctor in the US anyway,
Yeah.
write a prescription,
That's where I was going.
comes in a unit dose of 250 milligrams. the data from animals and people says that if you gave that dose to somebody with Parkinson's, you would be very, very likely to worsen their Parkinson's and need to get them to the emergency room.
Because it's such a high dose?
It's a high dose. So we started to manufacture our own supply to use in clinical trials. That's just about done now.
So if you're manufacturing, you still have to pay a license fee to the
No,
patent holder?
no, because the patent for the drug expired. It's from the 1970s.
Okay.
We secured a new patent called a method of use patent.
Yes.
And with that patent, we can protect the business because we're not going to get investors if we don't have a way to protect the business.
Yes.
So we're manufacturing tablets. The lowest dose is 40 milligrams. So we're going to start at
Versus the
40
250
milligrams.
commonly available
Right.
heretofore.
Right. So I would
And that'd
not
be in a
once.
pill form?
Yeah, we have ours are pills, not capsules.
And going through the genome, the gut biome, what does it do to the medication?
It's not clear that it does very much. One of the nice things about a repurposed drug is that there's a lot of data that already exists that's published.
It says it's safe.
And not only that, but it tells us that the drug is really not metabolized. So most of it is excreted, that's not absorbed, is excreted unchanged in the stool.
But
so the microbiome probably doesn't do very much.
So it doesn't get to the bloodstream.
So it gets absorbed. So anything that's not absorbed, that's excreted in the feces is unchanged.
Yes.
So it doesn't get metabolized.
Interesting.
By any of the microbiome.
So how long have you been at this?
Well, Ivan drove me over the edge with his pestering to start reading about Parkinson's in late 2017. So Thanksgiving 2017 was when I first started to read about Parkinson's to see if I could figure things out.
And at that time, you're a practicing cardiologist, you're teaching at Columbia. Life is pretty normal and pretty exciting because you get to do this wonderful work.
Yeah, by 2017, I had already stopped practicing cardiology. I had left cardiology, worked in a senior position at the FDA for several years, worked in the inner circle at DARPA for several years, done a bunch of work consulting for companies, helping them to design clinical trials and engage with the FDA. And so I was working as a busy consultant. But in that industry, consulting to pharma and device companies, they basically shut down Thanksgiving to New Year's to finish stuff off. There's no work.
Yep.
So I sort of said to myself, well, I got to get Ivan off my back. And I don't do anything in December anyway. So, okay, Ivan, I'll give it a month.
Yeah.
And in that first month was when I realized I hadn't read the German papers yet.
Yeah.
Took a little longer to track those down. But that's when I realized that there was a problem with how the disease was being treated, because there were a bunch of places where there were questions that didn't match with answers. For example, I went with Ivan to one of his doctor's appointments and I said, hey, look, I'm reading the textbooks now. I'm here to help Ivan. I know I'm
sure
just a
that doctor was
cardiologist.
really thrilled to have that dialogue with you.
He loved it. And so maybe I just don't understand enough, but since we're taught that this is a disease of dopamine deficiency and you're giving Ivan all of these drugs to increase the amount of dopamine in his brain.
And it's not working.
But he's getting worse.
Yes.
It's not fixing it. How can you conclude that it's a disease of dopamine deficiency? A disease of dopamine deficiency should be fixed by giving dopamine.
Yeah.
And he paused for what seemed like a really long time. It was probably only 4 or 5 seconds, but it seemed like a while. And he said, you just don't understand the disease. So then I said,
You're
okay,
right.
Explain it. Answer the question. He said, it's too complicated to go into now. And that's when I knew that I was onto something. When I started asking questions like that and people couldn't give me an actual answer.
So fast forward, how much of your time do you spend on this project now?
For the last couple of years, I've been spending full time on this project. It needed it.
Yeah.
And that's because I don't have funding. I have a little bit of funding. I'm working to fund and raise enough money to do the first trial. So most of this has been either asking people I know to help or getting people to help on the cheap, and we've accomplished an incredible amount. We've basically not only did we file and were awarded a patent in the US, it's looking like that's going to happen in Europe. There's one moving along in Asia. We've got some more that are in development.
It's very expensive to do, no?
Yes. We've formed a small network of Parkinson's experts with whom I've shared these data, who have been willing to look at it, who are on board. A couple of them
Well,
on our
that's new.
scientific advisory board. A couple more are ready and willing to talk to investors to explain why this makes sense.
Uh-huh.
And we've figured out what it's going to cost by getting a trial together and then getting CRO bids in place. A big step has been realizing we needed to manufacture the drug.
Yeah.
So we have to.
That's new too.
Yep. So we manufactured the drug substance, which is like you can think of it as the powder.
Yeah.
And then we were able to figure out how to turn that into tablets that were stable and safe for people to take. And now we're actually taking that drug substance and forming it into tablets. So that's just being tested now for quality assessment. So that's ready to be used in a clinical trial. So we've really advanced pretty nicely to the point where we could, if we could raise the money in the next few months, to enough money to do the trial, that we'd be dosing within about 3 months of that.
How much do you need to get to that next step?
We need 5 million. We've raised over 1 million now. We have 5 million to go.
1 million to go.
5 million to go.
So you said you need 5.
We need 5 million in addition to the 1.25 million we've raised.
Gotcha. Okay. And where would you do those trials?
Well, we had originally planned to do them in the US. It seemed very logical because it's a drug that was approved in the US, so the regulators really had experience with it. It was only approved in Japan within the last 5 years, and those are the only 2 countries. But what's been going on lately at the FDA has given us pause about doing it in the US because the FDA is now even more underpowered to do the work they need to do. So having worked there, I know that people were already working more than they were supposed to. And now with the reduction in
Good
force,
people, well-intentioned.
good people, really smart people with incredible experience. And now with estimates of 17 to 19% less people at the agency, and probably more of a drop in some areas, less of a drop in others, but that kind of drop means there's no way they can do the same. They have the same amount of work. They can't do it as effectively or as efficiently. So in order to get some predictability, we started to look at Australia. And we're just about at a point where we've got things lined up and contracts signed to do the trial there.
What would, couple of questions, doctor. You do the clinical trials, you get approval, and people say yes. From a business point of view, how do you construct things that there's an enterprise that would be able to go to market with this, work with the other people that you need to work with to get this to be an approved and recommended treatment modality for Parkinson's? Would that be a for-profit business that you're already set up or setting up?
Yeah, the reality is to get a product to the market in whatever country, you're talking 9 figures at least. So 100 million to 500 million. There are people who say it costs $1 billion per drug, but that I think is based on the cost, amortizing the cost of the failures in there.
Yes.
But certainly you're talking over $100 million. It's not realistic to expect a foundation to donate that,
right,
or a billionaire to say, "Oh, here's $100 million of my value to put into it." So you have to
pharma companies.
You have to set up a business.
Those rails.
So you have to set up a business, and we've set up that business. The money we've raised so far has been as an investment. The rest of the money will be as an investment. This is so-called seed round funding. That'll allow us to do this first trial and be in a position to launch the next one. That'll require our Series A funding, which is probably around $30 million. And that'll take us to the end of phase 2, which is the point in development.
Phase 1, $6 million. To get to phase 2, through phase 2 is $30 million.
So phase 1, we actually skip. Phase 1 is on normal volunteers because it's an already approved drug, repurposed. So we're doing a phase 2A and phase 2B.
What?
So phase 2A, which is to find the right dose
Uh-huh.
for the bigger trial, is the one that's going to run about $6 million
In Australia.
in Australia. Phase 2B, which will be over 100 people, will be in the US and maybe a little bit in Australia too, but primarily in the US. That's a $30 million purchase,
Yep.
cost, investment. Those data together, if the drug works even close to how it works in the preclinical laboratory models, will basically put us in a position where we'd be ready to start phase 3, which is the final set of studies or study to get market approval. But typically at $100 million investment for a phase 3 like this
You
would
sell the
require
company or?
the people who would put that money up would want to buy the company.
Yes. Got it. And the people who would be interested in putting that money up, would they be pharma companies?
To buy the company would be pharma biotech companies,
Yes.
yes.
So you're a mini little biotech company. And so if people wanted to invest in that, because they have they think it's a good business investment, or they have a personal interest in that, they would. Is it a donation, or is it an investment, or is it either?
Well, it'd be an investment.
And everyone who's a qualified investor knows that they're a qualified investor.
Correct.
Wow, amazing, amazing journey you've been on, and you tell the story so well. Your passion drips through. Uh, what have you been doing for income while you've been burning your candle on this effort?
So did you ask that question because you think my wife's going to be listening to get me into trouble?
Probably, yeah.
Yeah. Well, let's go to the next question.
It's been a strain.
Yes. But Jim, the thing is, there are not many times in life when you see data that are so strong that say this is a chance to conquer the disease. It's like how can you walk away from that?
Yeah.
It's just you just can't do it. And certainly there are times that are frustrating. There are a lot of times that are overwhelming where I'll be thinking, oh my God, now I've got to take on this project. And I have those panic moments pretty frequently, I will admit.
Yeah.
And what I do is I just sit down with a pen and paper, old-fashioned way, and I break down the task into the small steps. And you just start knocking a small step off. And at the end of the day, you've done a couple. At the end of the month, you've done a few more. And all of a sudden, you've got control of the big project. So that I can overcome. The part that I'm having trouble figuring out how to overcome is trying to get the status quo, the powers that be, whether we're talking about docs or institutions or foundations, to step back and realize I could be right. So they object. They say, we're not going to fund. We're not interested. We're not going to talk to you. But they need to ask themselves, what if this guy's right?
Mm.
He's got a lot of data supporting what he's saying. He has a track record of taking on causes that nobody thought were right and being proven correct. And this is a big problem where there hasn't been a breakthrough. I was about to say since, but I'm thinking back, when was there a breakthrough? I mean, look, the dopaminergic drugs are amazing. They help people function. I'm not trying to minimize that.
Yeah.
But the disease keeps progressing. People become more disabled.
Are they able to retard the progression?
No, nothing slows the progression.
Is that right?
Nothing. They're all palliative. So you've got foundations like the Michael J. Fox Foundation that is committed to curing the disease. I usually say I'm committed to conquering the disease because biology always wins in the end.
Yes.
But, if I can beat back biology for 10 or 15 years, that's a conquer.
Yes.
That's good. They have no contingency for the possibility that I could be right. They're just going on their paths, spending their $300 million a year
Is that how
on, according to the last 990 I could see, on fantastic research that's making us smarter, but they haven't come up with one therapeutic advance that conquers the disease, that stops the progression, that reverses the progression.
Yeah.
So why not spring for $5 million to have a contingency, hedge their bets.
So on your fantasy,
Yeah.
on the pad where if this happened, nirvana, someone like the foundation stepping up and Michael J. Fox or some other foundation stepping up and saying, here's the $5 million, it's an investment. Are you guys going to invest in you?
Well, Michael J. Fox generally gives grants.
Grants.
I would take...
And they could give you a grant even though you're not in a
Correct. Yeah, I applied for a grant. They rejected the application.
Yeah, without reason.
Well,
they gave, I fix this.
They gave reasons, but nothing in the reasons cited any scientific data that showed that our approach was flawed. They cited the conventional way that people talk about the data as reasons for not believing, apparently, but they didn't actually come up with a reason. So somebody could give a grant, like Michael J. Fox. Someone could invest. I mean, I'm happy to share the upside.
Some really good YouTube videos about statins. And again, the conventional thinking. I started using a statin personally maybe 20 years ago because I had a friend who ran a pharma company, not in the area of statins at all. But we were traveling together, and he said, do you take a statin? I said, no, my cholesterol's good. He said, well, it could always be better. And he said, why don't you take a statin? I said, well, why should I? He said, because it's the greatest drug of a generation. It's a wonder drug. He says, I take it. So I saw my general practitioner, who's still my general practitioner, a wonderful guy. And I said, this is what my friend said. He said, okay, we'll give it a try. So he started me on a statin. I recently stopped taking it because the side effects were building. Now, this is over 20 years I've been taking it, but the side effects are getting worse and worse. And now I've watched several scientists talk about everything we thought we knew might be flawed, and maybe we all shouldn't be taking statins. And so you can see, even just from my little point of view in my corner of the world, that dogma and concentrated thought aren't always right. And sometimes they're dramatically wrong.
We're here to learn. And certainly if you're involved in public health and medicine, in the research supporting either of those disciplines, the goal is to get smarter in a way that helps people day to day, day in and day out. And when groupthink is as prevalent as it tends to be in human groups, it's a battle, but it's a battle that we can win.
Any idea how Secretary Kennedy thinks about this, or does he? Does he have a point of view on this?
I haven't heard one, and I'm not looking for that kind of visibility. I'm looking for funding so we can develop data.
Yeah. Well, he seems to be pretty data driven, and you're doing amazing work. So we have to who would it be beneficial in our audience to get in touch with you?
Well, I do hear from patients who are aware of my work, and I'm sure that'll happen again because people are going to listen to this podcast. I try to respond, but generally I don't respond to most of those.
Because you have a day job.
Because I have stuff to do. But I appreciate those kinds of emails. They're really helpful when people email me and say, we need something, thanks for fighting the fight.
And where would they email you?
Well, you can go to the best thing to do is to go to my blog, which is parkinsonsdisease.blog. I have a weekly newsletter I put out. I talk about Parkinson's disease. I give updates on this program, this development program. And you can find my email that way.
Good. So they would go to parkinsonsdisease.blog.
Exactly.
And they can find your contact information and all there, and sign up for the newsletter. And I get some really interesting stuff there. Well, I wish you Godspeed, and we'll do what we can to help make the right introductions. And we have an amazing audience, and I'm not going to be the least bit surprised when something dramatic happens from people hearing your story. You're amazing, and we wish you great success and speedy success at that.
Speedy success is going to be key. Thank you, Jim.
Thanks, Doc.